Do you use an iPhone?
Mhm.
Are you good with them?
I like to think I am.
Maybe I'll ask you after class. Something peculiar has happened. My it seems to be no longer syncing up with my email, so that
Did you download the latest update? They threw out an emergency update over the weekend.
oh really?
Settings general.
Oh, all right. Yeah, I guess I
Try
got
that first.
to plug it in later. See that. All right, cool. Thanks.
9 times out of 10, that fixes the issues. Otherwise, it sounds like your mail came out of sync somehow. You have to re-sign in.
I mean, I thought it might. I had to reset my email password, so maybe that's
why.
I just can't seem to figure out how to.
You have to go back into your account and change your password in the account.
On the phone?
Yes.
Maybe you could show me how to do that. No big.
It's always a pain when you have to change your password.
So through much agony and trial and error this weekend, I made a special page for each function with one related transformation. I'm starting to remember the damn thing.
The thing soon you have to make another page with all the trig identities that we're going to go over.
Well, I have the 6. You know,
Those are the functions.
Oh,
We're gonna be doing identities soon. There are quite a few of them.
Well, it's a big notebook.
You're late. Happy Monday. Start off another week with beautiful weather, only have the weekend be crap, probably.
Oh, really?
It's probably gonna wind up happening. We met last Monday. Right, we finished up with the trig functions. Then you were to do properties of the trig functions on your own, right? So period, amplitude, the graphs, phase shift, midlines in the textbook. It's not too difficult. Today, we're going to finish up the unit by looking at the inverse trig functions. That means, yes, your trig test is going to go live today.
Today?
Yep, because we're going to finish up the unit. And then we do analytic trig on Wednesday.
We're going to use.
Well, this is inverse trig.
Go inverse.
Now, remember, to have an inverse, it had to be 1-to-1. The trig functions are not 1-to-1. So how can they have inverse functions? Because we restrict the domain.
Okay.
So technically speaking, the trig functions do not have inverses because they're not 1-to-1. But if we first restrict their domains, then they will have an inverse on that domain only. Keep in mind that that means that the inverse trig functions are going to have restricted range.
Well, they all have restricted range. You meant, did you? Oh, well, okay.
Well, the range of sine
Cosine
is
tan, yeah,
is negative 1 to 1.
Yeah, the tangent.
But that's I'm talking about the inverse is going to have a restricted range because I'm restricting the domain of the trig function.
Right.
So the inverse is going to have a restricted range. Its range is not going to give you all the possible angles.
Really? So like inverse cosine is not going to have a range of 1 to 1 again? Okay, all right, let's see what happens. So we're.
Start with sine. We're going to restrict its domain to make it 1 to 1. There are several ways to do this. The way that it was done was to go minus pi over 2 to pi over 2. That would be the right half of the unit circle. That guarantees every value in the range minus 1 to 1. That means that the inverse sine function will have domain minus 1 to 1 and range minus pi over 2 to pi over 2.
And that's sine negative 1x. Just switch the two around.
Which is tricky. That's quadrant 4 and quadrant 1. What if we want a quadrant 3 angle instead? The inverse sine will not give it to us. So we have to correct it. This is a case where you shouldn't just blindly type stuff into your calculator. The calculator is only as smart as you are. So for instance, if you put in inverse sine of negative 1, it's going to give you negative pi over 2. But 3 pi over 2 is more accepted as an answer. You put in inverse sine of negative root 2 over 2, it's going to give you negative pi over 4. However, 5 pi over 4 is also an angle. That's the quadrant 3 angle. And maybe that's the angle we want. So you actually have to look at the problem and not just blindly rely on your calculator. I'm going to section them off together, so each trig function is with its inverse. For cosine, restrict the domain to 0 to pi. That is the top half of the unit circle. That'll still give us every value in the range. Means that the inverse cosine function will have a range of 0 to pi. And again, same problem as with the inverse sine. That only give us quadrant 1 and 2. But we can also want quadrant 3 and 4 angles. There's another notation commonly used for the inverse trig functions. It's the arc notation. Arc sine, arc cosine, so on and so forth. They are used interchangeably. Keep in mind that while that is true, that is not. This is the inverse sine function, not sine to the -1 power, which would be cosecant. Whereas this is the square of the sine function. So you're going to have to keep that notation straight, which is why we have the arc notation. If you don't want to confuse yourself, use that. Tangent. Restrict the domain to minus pi over 2 to pi over 2. Non-inclusive. Right, and that clearly means inverse tangent is going to have a range of minus pi over 2 to pi over 2 non-inclusive. I think it is this one. Secant or restricted domain 0 to pi over 2 union pi over 2 to pi. Where? Here? Yeah, that's 0. For cosecant, negative pi over 2 to 0 union with 0 to pi over 2. Finally, the cotangent. Actually, forget the convention for cotangent. I think it might be the same as secant. No.
Wait, how is the range for secant everything? I thought the curves hit 1 and -1 and then headed off towards infinities again. Isn't the secant curve like and then
Oh, no, you're right. Yeah, this wouldn't be that.
it would be like with -1 and 1, right? Or yeah, negative. Okay, yeah.
And it's the same thing with the cosecant. That's right. Cotangent restricted to 0 to pi non-inclusive. The definition of the inverse trig functions, I'm not going to write out all 6. I'm only going to write out sine because they're all the same. You just switch the function. Y equals inverse sine of x if and only if x equals sine of y. All right, so again, similar to the definition for the logs. So when you're asked for the inverse sine of something, what you're being asked is what angle gives you that value. Right, so sine of what angle gives you that value? So inverse sine of 1/2. You ask sine of what angle is 1/2. And that's what the inverse sine gives you. But remember, you're restricted in your domain, in your range. Right, for inverse sine, it happens to be minus pi over 2 to pi over 2. So we're going to evaluate 12 expressions. Sine of the inverse sine of 1/2.
Just undo each other.
They do just undo each other. It's 1/2. Now they only undo each other as long as what you're taking the inverse sine of is in the domain or in the range of sine. Right, so if that was inverse sine of 2, that'd be undefined. Cosine of the inverse cosine of minus 1/2. Well, minus 1/2 is in the range of cosine, so it'd just be minus 1/2. They undo each other. Cosine of the inverse sine of negative root 2 over 2. Well, in this case, what we want to do is evaluate inverse sine of negative root 2 over 2 first. From minus pi over 2 to pi over 2, sine of what angle is negative root 2 over 2?
As pi or as degrees?
It's always radians.
Radians.
What happened? Three pi over 4 is not between minus pi over 2 and pi over 2.
Oh, oh. Oh.
First thing you want to ask yourself is, what quadrant are we dealing in? For inverse sine, the range is what quadrants?
Third and fourth? Shit. You don't want y negative?
Remember, range has to cover all values. So when we restrict the domain of sine, we wanted to get everything between -1 and +1. All you really have to do is refer back to your notes, because we did write out that chart. Range or inverse sine. You're going too far back.
Which is what we just did. It's negative pi over 2 to pi over 2,
What quadrants are they?
fourth and first.
Of those two, which quadrant assign negative in? So you're looking for a value between negative pi over 2 and 0. So between negative pi over 2 and 0, where is sine negative root 2 over 2?
Wait, slow down. Repeat that last part again.
Between negative pi over 2 and 0, where is sine negative root 2 over 2?
Negative pi over 4.
So the inverse sine of negative root 2 over 2 is minus pi over 4. Another way you can do it is just look in the first quadrant and say, where's sine root 2 over 2? Pi over 4. What angle is that a reference for in quadrant 4? Minus pi over 4. So I said you really need to memorize the first quadrant. Now, what is the cosine of negative pi over 4? Okay. So what's your reference angle going to be? Make it an acute angle. So what's the reference angle for minus pi over 4?
In degrees?
Never degrees.
I guess just pi over 4.
Be
Right?
pi over 4. What's the cosine of pi over 4?
2 over 2.
In quadrant 4, is cosine positive or negative? So cosine of negative pi over 4 is root 2 over 2. As long as you know your quadrant 1, you can do anything. And again, if you only need to know quadrant 1 for sine and cosine, and you can get everything from just that. This is why trig is sexy. Inverse sine of sine of pi over 3.
Just undoing each other again.
So pi over 3.
Well, that's my guess. My hunch. I mean, yeah, because you would take the sine of pi over 3, and then you would say, what angle gives you that answer, right? Which would bring you back to pi over 3. I hope.
Pi over 3. Inverse cosine of cosine of minus pi over 4.
So that angle negative pi over 4 has to be in the range of cosine? No.
Damn, I'm gonna trick you. So you'd say minus pi over 4. So I could laugh. You're right. Has to be in the range.
So what, we just use the reference angle?
So this is where you just have to evaluate cosine of minus pi over 4 first. And then find the inverse cosine of that, right? Because you can't get minus pi over 4 out of inverse cosine. Right? What's the range for inverse cosine? So minus pi over 4 wouldn't make sense. There we go. It's the inverse cosine of, now what's the cosine of minus pi over 4? We just did it. So root 2 over 2.
Yeah.
Right? Now you go, okay. Range is 0 to pi, which is what quadrants? And
1, 2.
in which of those is cosine going to be positive? So you're looking for an angle between 0 and pi over 2. Of those angles, which one gives cosine as root 2 over 2? So the inverse cosine of the cosine of minus pi over 4 is pi over 4. Inverse sine of the tangent of 3 pi over 4.
You scroll up just or down for just 1 second. I just want to see something on number 2 again.
Scroll down.
Let's get back.
That's up.
Thank you. Oh, yeah, okay. Always helps to copy the thing down, right?
That definitely does help. Of course, I can also argue it helps if I write the problem correctly. Because I've done that before too, where I didn't write it out correctly, and then everyone's confused, and I'm going, why the hell is everyone confused? And I reread the problem. And I go, okay. The tangent of 3 pi over 4. No, it's not.
Here.
Use your reference angle. What would your reference angle be?
Oh. Just pi over 4.
What's tangent of pi over 4?
1.
Where is 3 pi over 4 located? What quadrant? Is tangent positive or negative? So tangent of 3 pi over 4 is -1. What is the inverse sine of -1? Yes. Because again, you have to remember you're restricted to -pi over 2 to pi over 2. -1 would be the negative y-axis, which has an angle of -pi over 2. Inverse cosine of tangent of -5 pi over 4. Question.
Thank you.
What is the tangent of -5 pi over 4?
Same as 3 pi over 4, right? Co-terminal.
Now, what is the inverse cosine of -1? Cosine is -1 on the negative x-axis, which has an angle of pi. Cosine of the inverse sine of 3/5. Now remember, the inverse sine is going to give us an angle, right? Call that angle inverse sine of 3/5. Three over 5. All right, so how are sine defined? In terms of coordinate plane?
Sine.
Yeah.
Pi over 1. Y over R.
Y over R.
R. Yes, R.
So for inverse sine of 3/5, what would the y be?
That'd be 3.
What quadrant are we in?
Both positive. So first,
What do you mean they were both positive?
I'm 3 and 5.
Right, but R is always positive, isn't it?
Yeah. So then it has to be first,
Why?
because, oh,
You're overthinking this. You just told me Y is positive, right?
yeah.
So where is Y positive,
One in the first and second.
right? But it can only be one of those quadrants. So which one is it?
The first,
Why?
because it's in the range of,
Yep, because inverse sine is only quadrant 4 and quadrant 1. That means we're dealing with an acute angle. So we can use right triangle trigonometry for this. Let's call this our angle theta. Now, in right triangle trigonometry, how is sine defined? What's the missing length? Which is what? What's the measure? This is one of the most common right triangles.
three, four, five.
How is cosine defined? The cosine of theta is 4/5. But didn't we say theta is the inverse sine of 3/5? So the cosine of the inverse sine of 3/5 is 4/5. Sine of the inverse cosine of -2/3. Again, just call theta the inverse cosine of -2/3. So we're going to try and find where theta is located. What is x?
-2.
-2. What quadrant are we in?
Second.
Why second?
Y is gonna be, because because the cosine value is negative. And cosine is still negative. Oh, second or third? Shit.
It can only be one of them. Why? The range is 0 to pi, right? Which is quadrant 1 and 2. So we're in quadrant 2. Bummer, it's not an acute angle. Technically, we can't use right triangle trigonometry. But I can if I modify it. Just because I don't feel like drawing out a coordinate plane. If you imagine this being the negative x-axis for quadrant 2, right? So the base will be the negative x, the y will be the height. We'll let that be theta. Because I'm going to treat theta as an acute angle. Cosine. How is cosine defined for right triangle trigonometry?
A over H.
What is our missing length?
Oh, the vertical leg.
Which is what? What's the measure?
√5.
Now here's where the modification comes in. We're dealing with quadrant 2. What is the sign of sine in quadrant 2? So I can just use these values. If it was negative, I'd just put a negative out in front. So what is sine of theta? So there's sine of the inverse cosine of negative 2/3 √5 over 3. And that was the argument I used in my mind. Tangent of the inverse secant, oh, there we go, of minus 5/2. What is the range of the inverse secant?
Beginning with 5/2.
So if we're taking the inverse secant of a negative number, then our angle has to be between what values?
Zero and pi, except for pi/2.
It's too broad. You can restrict that. So if you look at the range, 0 to pi/2 union pi/2 to pi, what quadrants are we dealing with?
Second.
Right? And we take out the y-axis. Technically, it's not in a quadrant, right? Axes aren't quadrants. Of those two quadrants, where is secant going to be negative?
Trick question.
Quadrant 2. So what does theta go from? So what are the angles in quadrant 2?
Oh, just thinking of cosecant curve. Wait a second, secant is.
You don't want, we're not talking about the graph of secant.
Let's make that.
And so what angles are quadrant 2?
Secant. It's pi/2 to pi.
That means that the value of the inverse secant is going to be between pi/2 and pi. What's the sign of tangent for those angles? In other words, tangent is what in quadrant 2?
Negative.
So our answer is going to have to be negative. Now we use our reference angle. Treat it as an acute angle. That is theta. How do you define secant in right triangle trigonometry? Then what is the missing length? What would the tangent, I'm actually gonna call this, I think this time theta prime to represent a reference angle. So what would the tangent of theta prime be?
One over two.
So tangent of our angle would be negative that, because we're in quadrant 2. So remember, theta was the inverse secant of negative 5/2. So we get negative root 21 over 2. Cotangent of the inverse cosine of 3.
First or the cosine answer is positive. So right, you say what quadrants is cosine positive in? Right, we like first question, I guess.
Okay.
So cosine is positive in quadrants 1, 4.
Okay.
Okay. Now, I can. Three over eight. Gotta be. Are you gonna, so, right, the cosine equals 3. The cosine of what angle equals 3? Right? That's what we're trying to find out first.
Mm-hmm.
Okay. And
Go back and look at the domain for inverse cosine.
something like that. So it's outside the domain.
This expression is undefined. Going the route you were trying to go, form your right triangle.
Yeah, I thought it was gonna have leg 3 and a hypotenuse of 9. You get like,
That's not possible.
no, that is not possible.
3 is not 3/9.
1/3.
3 is 3/1.
And that.
Or 9/3.
ratio, which would make the.
Right, that makes the hypotenuse shorter than the height, which is not possible. Hypotenuse is always the longest.
Too big, have to be 1 or less.
Be careful.
Well, 1 between 1 and -1,
Yes.
yeah.
This expression is undefined because 3 is not in the domain of the inverse cosine function. So inverse cosine of 3 itself is undefined. See, you're getting comfortable, and then I threw a curveball for strike 3 swinging.
Just when I thought.
It was the bottom of the 9th, bases loaded, 3-2 count, down by 1. And I threw a nasty curve to get the save. Wish the Phillies could have done that yesterday. I'm not bitter at all. Only good thing is at least they did it before I ate dinner. So at least dinner cheered me up. I knew something like this was going to have to show up. Sine of the inverse cosine of x. First thing to note. Range of inverse cosine is what? From 0 to pi, is sine positive, negative, or both? Positive. That is important to note.
The sine and cosine are always positive.
Sine is always positive.
Sine.
Because inverse cosine is 0 to pi.
Inverse cosine range is 0 to pi.
So let theta be the inverse cosine of x. Form your right triangle. We're going to treat theta as an acute angle. Given that theta is the inverse cosine of x, what two sides of the triangle do we know? Of course, the assumption is that x is somewhere between -1 and +1, right, to make it defined.
So this hypotenuse is 1. Base is x.
Then what is our missing length?
Square root of 1 minus x squared.
How would you define sine of theta? It's what?
Oh, It's just root 1 minus x squared.
Is that guaranteed to always be positive? It's not?
Yes,
Yes.
because
Square root is always positive. When you take the square root of a value, always gives you a positive. Well, less than or equal to. Absolute value of x is less than or equal to 1. This expression is also always defined because x is always between -1 and +1. So the square of those values are going to be between 0 and 1. And so you always get the square root of a positive number. So sine of the inverse cosine of x is the square root of 1 minus x squared. I'm gonna give you a piece of advice. You can always simplify trig of an inverse trig or inverse trig of a trig, no matter what. Even if that simplification is it's undefined. So if the expression itself is defined, it can be simplified always. Meaning, let's say we're doing something. Let's call this calc 2. We're doing an integral, and we get sine of inverse cosine of x. That is an unacceptable answer because it can be simplified. It simplifies the square root of 1 minus x squared. Right? I don't know, we're solving something and we get tangent of the inverse secant of -5/2. That form is unacceptable because that can be simplified down to negative root 21/2. I don't know how other instructors are. Get me for calc 1 or calc 2, I would not accept an answer of that form. You would lose points. I would not accept an answer of this form. You would lose points. As a general rule, everyone should be like that. If it can be simplified, simplify it. Once we learn the identities, even something like sine of pi over 12 is not acceptable. That can be simplified. That has an exact form. We're going to learn how to do it. There's actually 2 ways you can do that. You can use a sum difference identity or the half angle identity.
sine of
Pi over 12
is so sine of, what about sine of pi over 4?
Well, sine of pi over 4 is easy. Root 2 over 2.
Okay.
Sine of pi over 12 can be simplified with the identities. You can do it either using a sum difference identity, right? So write pi over 12 as the sum or difference of known angles, or do it as a half angle. Pi over 12 is 1/2 pi over 6.
Okay. Yeah.
And then
Which
there's
is
an
in turn
identity
half of pi over 3.
that gives you an identity. Well, pi over 6 is a known angle,
Oh.
which then using identity, you can get an exact form. You can't do it yet, right? We haven't gone over it.
Well, you'll quiz us on that.
Not until we go over it, which is next week.
And Mr. Professor, when can we expect to see our grades from the last test?
When I grade them.
Did you have to confirm what the passing grade is for this class?
Well, it depends on policies. To transfer, you need a 70. Because you need a C minus to transfer.
To pass,
Technically, a D is
Yeah.
passing.
to get to. Be passing grade.
I think a D. But you have to double check that.
So again, it's not on you, it's on the school.
Again, technically a D is passing. But the department may have put a requirement in with a C minus as the prereq, in which case it'd have to be a 70. But you can easily go online, look up mccc.edu academics, look up the syllabi. Open up the Calc 1 syllabi, it'll be right in their prerequisite. It'll say pre-calc with a minimum grade of C minus.
So. Grade of a B 82, something like that is encouraged before taking calc,
Encouraged, but not required.
but not required.
Then a D. All you have to do is pass.
Our classes specific to.
Right, but again, you have to look up your. If you're just looking to advance the Calc 1, that's what the syllabus said, a D.
Yeah.
But if you wanted to actually challenge your major, you have to talk to your actual major because they may require a certain grade.
I want to understand the psych.
And transfer is a C minus. That's true across the board.
Say you're.
Again, it depends. Because at Rowan, I got a D in one of my physics courses, and I could have actually just taken that and got my degree. Of course, I didn't want to keep that D, so I did retake it, but I could have just not retaken it and still would have got my degree. Because all that they require was a minimum GPA in your physics courses. So again, it depends on every major is different. And every instructor is different with at least the grading scale. Right, so if my C minus was a 60, you need a 60. Because they don't see that, they don't actually see the letter, I'm sorry, the numerical grade on a transcript. They just see the letter. Which does suck because that means an A, 193 are identical.
Oh, really? There's no such thing as an A plus
Nope.
anymore? That's,
Technically, there's never been an A plus.
Oh.
Doesn't fit into the GPA scale. 4.0 is an A.
or yeah, well, I know. I mean, sometimes you hear like, oh, 4.3 or whatever.
That's only for honors courses in high school. College, 4.0 is the highest.
Plus in there, and that is really like, so technically nobody's actually like,
Well, because there is a C plus in the GPA.
just.
It's a 2.7. There's also a D plus and a D minus in the GPA. 1.7 is a D plus, no. A 1.3 is a D plus. A 0.7 is a D minus. Right, 3.7 is an A minus. 3.5 would be a B. Or B
What?
plus.
Oh.
3.0 is a B. Works along that scaling. So technically schools should have A minus, B plus B, B minus, C plus C, C minus, D plus D, D minus, and F. But they don't. But that's how that works. So as long as you get an A, it's a 4.0 for that course. Whether it's a 93, a 98, a 100. Counts the same for your GPA scaling. That was off topic, but not really. And actually, calculating your GPA is also fun. If you know the right formula. Higher credits affect it more than lower credits. Yeah, 4-credit course will have a heavier effect than a 1-credit course on the GPA. An A in a 4-credit course is 16 credit points. A 1-credit course A is 4 credit points. The weighted average. 8. I didn't know they were allowed to do that because that means you'd have to meet for 8 credit hours a week. So that'd be
For like 3 hours each time.
so it'd be 8 hours minus 80 minutes, which is an hour and 20 minutes. It'd be what, 6 hours and 40 minutes a week you have to meet. That'd be 3 hours and 20 minutes a day for 2 days a week.
That's- Except we would only meet once for 3 hours, and 20 minutes from 9 to 1, pretty much on Saturdays. It's awful.
Then that's on an 8-credit course. If you only meet once a week, then it has to be a 6 hour and 40-minute meeting.
But it was, so we had assignments due on Wednesday and Saturday each week. 2 different classes, but we only.
Was it a hybrid class? That's why.
Can I just ask a general overview on this? So just this last one. The first thing you say is, okay, cosine, inverse cosine of negative x. So you look at your range
Mhm.
for inverse cosine. And the range is 0 to pi.
Yep.
So then in that range of 0 to pi, but it needs to be positive. Wait, damn it.
From 0 to pi, what is sine?
Sine is positive.
From 0 to pi.
Yeah, sine is positive.
Yes. So we know that sine of the inverse cosine is going to be positive.
Okay. So therefore, x has to be positive because if x was no,
X can be negative. Because what happens when you take a negative and square it? And you get 1 minus a positive value less than 1. So you can take the square root of that, and the square root always gives you a positive value.
so all you really had to do for that was draw your
Yes.
reference triangle.
Because sine is always guaranteed to be positive. If it was something like tangent from 0 to pi, it could be positive or negative. I'd have to write out 2 functions. It would be a piecewise defined function. One is positive from 0 to pi over 2. One would be negative from pi over 2 to pi. Right, because tangent's positive 0 to pi over 2 and negative pi over 2 to pi.
For number 10, could we just go over it real quick? Why are we doing, put in the inverse secant equal into theta? Because we're trying to use the right angle trig.
Because, well, remember, inverse secant and inverse trig function is going to give you an angle. All right, so just to draw it out, I just said let it be theta, right? Because inverse secant of -5/2 is a specific value. I'm saying call that value theta. I called it theta prime because I'm treating this as the reference angle for the actual theta. Right, because theta itself, inverse secant of -5/2, right, is not an acute angle. It's an obtuse angle, right? It's in quadrant 2. So I'm saying let theta prime be that reference angle. be the reference angle for that. So I can do right triangle trigonometry. Right, then you just have to note that secant has to be negative, or tangent has to be negative because it's in quadrant 2 and tangent's negative there. Right, yes, is less than 0. Right, so whatever you get as tangent for your reference angle, you multiply that by -1, and that's tangent of the actual angle.
Multiply that by -1.
Yes, and that'd be the tangent of the actual angle. That's how reference angles work. All right, so with trig, you can essentially always work in the first quadrant. You can always work with acute angles. Because you just, if it's not an acute angle, just use a reference angle. Now it's acute. You just have to modify it at the end based on where you're located. For inverse, for this one, you have to look at the range of the inverse secant.
Pi 2 less than 0, 0 less than pi. That's the range. Oh wait, the range was
0 to pi over 2 union pi over 2 to pi, which is quadrant 1 and 2. Right. If it's not like an inverse, like I'm just saying, what is the tangent of 16 pi over 3? Right, you have to determine what quadrant is 16 pi over 3 located in. Then just use pi over 3 as your reference angle and modify accordingly. Right, 16 pi over 3 would be pi over 3 plus 15 pi over 3. Right, which is 5 pi. 5 pi is the negative x-axis, so we're in quadrant 3. So tangent would be positive in there. So tangent of 16 pi over 3 is tangent of pi over 3. Now I just take tangent of pi over 3 and I'm done. That's how reference angles work. Does that make sense?
it made sense, yeah.
And that, again, why trig is sexy. Any other questions? So I think in this unit, we were introduced to some of the basic identities. Right, so tangent sine over cosine, cotangent cosine over sine, secant 1 over cosine, cosecant 1 over sine. I think we also saw sine squared plus cosine squared equals 1. And then the two other Pythagorean identities from that, one that relates tangent squared and secant squared, one that relates cotangent squared, cosecant squared. I think those are the only identities. No, we also saw the cofunction identities, right? The sine of theta minus pi over 2 is cosine of theta. Right, cosine of theta minus pi over 2 is sine of theta. And then secant, cosecant have similar relations, tangent, cotangent have similar relations. We also saw those. So those are basic identities. What we're going to look at next is some more identities. So specifically, we're going to look at the sum difference identities. We're going to look at double angle identity, half angle identity, reduction identities, sum to product, and then product to sum. We're also going to look at verifying identities. Right, so you're going to be given an equation along a bunch of trig functions, right? So some trig expression equals some other trig effect expression. You have to verify it. Right, so in other words, get one side to match the other side using identities, and then solving trig equations. And then that'll be it for the semester. Solving trig equations is a lot different than what we've been doing. Right, because technically speaking, we're going to say it. Technically speaking, If a trig equation has a solution, it has an infinite number of solutions. Because the trig functions are periodic. So we're gonna have that to contend with as well. Fun times, I love trig. What is going on?
Is there a full answer key for the previous tests available?
Nope,
Will there be? one?
nope. Because you'll have to retake them.
Oh, really?
Yeah.
I totally forgot about that. Maybe I should.
Why'd I give you the solutions if you're allowed to retake it?
Well, no, not obviously not then. The very same test you're
Yep.
saying.
I don't know why I'm opening this one. Plus, I reuse tests, so I wouldn't make the solutions available. It's an easy one. Funny thing is, quiz 19 was also easy, yet only 5 people did it.
What, even the one we did online?
Mhm.
I hope I submitted mine properly.
You did.
I always worry about this. I'm an analog man in a digital world.
Well, you said only 5 people did the quiz.
And it was so easy. I purposely made it easy.
That's why you gave us, because you gave us the time limit. Between
I gave you 30 minutes to do it. That's also to account for uploading and technological issues.
Well, that's actually what,
You probably only needed like 2.
Didn't you just have it up from 3:30 to like 5:20?
I was so confused.
And I'm pretty sure if you started it, as long as you started it before close, you could have submitted it.
Oh, yeah, were you able to get that fixed?
I did.
Hopefully before it rains.
So.
Oh, nice.
it's probably the battery that needs replaced.
Yeah, because it keeps like ticking.
Yeah.
Did you grade that quiz?
It's going pop up.
Not yet. I just started grading my Calc 2 Unit 2 exams, which were due last week. I'm sorry, week before. I'm just about done everything that was due the week before.
Is there any ways to get any more homework extensions?
As long as you still have late passes.
Yeah, the late passes.
Yeah, as
No,
long-
I didn't finish all of them yet. I'm just wondering if.
As long as you still have late passes, you can still extend homeworks.
Yeah, I know, but
And reopen them up.
can you ask for more?
No. Number of late passes you have is fixed. So once you use them all, that's it. Unless you have a valid reason to extend an assignment, in which case then you won't need a late pass. All right, make sure everything's right. April 17th. Let me mark that down. Fourth test is now available. I think this is an extremely easy test. If I remember correctly, when I wrote up the solutions, it took me like 10 minutes. Right, so I figured should take you twice to 3 times as long. So it still shouldn't take you more than an hour. This is an extremely easy test. Probably the easiest of the semester, in my opinion. No, I'm sorry. I think test 3 was easier than this one. So the one that should make you think the most is question number 2. Everything else you shouldn't really need to think too hard. Right? As always, do it on loose leaf paper. Scan your test as a single PDF document, upload it by the due date. Can use any course materials, textbook, notes, anything I hand out, which I haven't handed anything out. Right? Any model graphing calculator does not involve symbolic manipulation, so just graphing calculators. Right? No CAS. Can't talk about this with anyone other than me. Why is that there? It's supposed to be its own line. All right, and of course, most importantly, as always, have fun. Which reminds me, while I'm thinking about, before I forget, final exam. Is scheduled for May 10th, 3 to 5. In this room. Well, the year's not over. I mean, if the year was over, I'd be a little worried because I'd be like, okay, well, where did June, July, August, September, October, November go? The semester's almost over. Which means the spring term is also almost over. 20%.
Get a 75 here.
Yeah, you get 15 points out of 100. In terms of the format of the final, I'll discuss that when I actually make up my mind, which will be closer to the final date.
It'll be on everything.
Oh yeah, has to be comprehensive. I don't have a choice there. The school makes me do comprehensive finals.
Is it open?
Probably be the same.
But here,
I haven't decided.
oh, could be honor lock
It won't be on the lock.
or,
I may
What?
make it take home.
oh, okay.
I may make it in class. I haven't decided yet.
Just for time reasons, I'll go to the. Five to finish this test as well.
Unfortunately, that's what's scheduled.
Yeah.
Like I said, I'll come up with a format. I'll come up with a format. Just remember, take home would be longer. I would write it with the 2 hours in mind. I did have an instructor who did make his tests impossible to finish in the time frame. I'm not like that. No, I wouldn't go that far either, because I don't make it easy either.
Challenging.
I like to think challenging but fair. Okie dokie.